Okay, I'm gonna cover the elimination reaction first. So what is the elimination reaction? Elimination reactions is the type of reaction that in which two substituents are removed from a molecule. They will have one step or two steps. It depends on if it's a E1 or E2. So for the E1 has occur only one step, and E2 occur only like two steps. But most of the time, E2 occur more favored than E1. E1 only occur when you have a strong solvent, strong solvent, strong nucleophile, and very high heat. So E1 occur. But bottom line is E1 barely occur. Most of the time, E2 will occur. And for example, we have this that one with the two substituents x and y, and you will have this any solvent or base, and you will end up with like we will remove the x and remove the y, and you will have the alkene. And sometimes you will have alkyl too, but we don't study that yet. So now it just focus on alkene. So so that's an elimination reaction. And for E1, tertiary, only tertiary can do for E1. And for E2, you have secondary, tertiary, and primary. E2 don't occur for the metal group. So the common base that used for the elimination reaction is this one. These are the common base, which is the alkyl ethoxide, sodium alkyl ethoxide. For example, these are the two common base, ETONA and in ETOH. That's the first solvent. And the second one is MEONA in MEOH. Remember, ETO gonna be the same, MOH gonna be the same. For example, I have this. Okay. It's a nuclear it's just a living group, and I'm put ETONA or MEONA, whatever you like, but you have to match with the solvent in which it dissolves, ETOH. And sometimes there's a heat too, but in the book it says sometimes it's a 55 Celsius degree, but I don't think it's necessary. So when you have the substrate, and which is the base in the solvent that used for elimination reaction, and you will have this double bond right there. And the mechanism is there's a hydrogen right there. The nucleophile is right here. They're gonna attack the hydrogen, and they're gonna form the bond right here. They're gonna form the double bond over here. And these two electrons right here, they're gonna move back to the iodine. So when you have the double bond right there, that's that kind of mechanism for elimination reaction. It's pretty simple like that. So another example, okay, and put it bromine, and then I'm gonna use two different base. The first one is I'm gonna use MEONA in MEOH. The second one is terbutoxide in terbutyl hydroxide. What's the difference between these two right here? This nucleophile in this solvent is a regular base. It's a hinder base, because a hinder base, so is prefer the McCup position, which is the more substituted side, which is this one, which is over here. That's a more substituted side. And for the terbutoxide, because it's a very bulky base, is like a big base, and it's unhindered base. So they prefer to create anti-Markovnikov elimination reaction, which is right here, like a least substituted. What else? Okay, that's kind of very common, like common concept for elimination reaction. Okay, let's move to the summary. Okay, we have method group, the primary, secondary, and tertiary. For the method group, there will be a SN2 only. For method, SN2 occur only. For primary substrate, it could be SN2 or E2. In here, for most of the time, we prefer SN2. Just when you have the base, when you have the base, is a butoxide, like this base right here, butoxide, you will have the E2 will occur. But most of the time, for primary reaction, is SN2. And one more thing, for primary substrate, when you have the primary substrate and the base and the strong base, for example, etoxide or methoxide, the substitution is highly favored because the base can easily approach the carbon bearing the leaving group. For example, this bromine, I'm going to use this base ETONA. In ETOH, I'm going to use some heat, just a decrease, and you will have the substitute reaction SN2. This, I'm going to use different color. Oh, that one. This is a 95%. This is 90% is SN2, and 10% is gonna be elimination reaction, which is this one, around just 10%. This is the E2 reaction. That's for the primary substrate. So again, when you have the primary substrate, most of the time SN2 occur because it's like unhindered base. It's very it's easier for nucleophile to attack in the leaving group and create a SN2 reaction. The only one way for the E2 reaction is the butoxide. For example, the same thing, the same substrate, but you use the butoxide. Oh, I'm going to use the other substrate. I'm going to use this. I'm going to use this substrate. Okay. I'm going to use this one. BR. That's the secondary. I'm going to use this. Okay. And I'm going to use the butoxide in a butyl hydroxide. And you will have elimination reaction, not a substitution reaction. SN2 still occur, but it's only maybe 10% because of the butoxide. So this right here is a 90% around that, and 10% is a substitution reaction, like this. Let's see. Oh, that. This is 10% for the SN2 reaction. But this is the major product. This is the minor product. Okay, that's for the primary reaction. A primary substrate. And for the secondary substrate, we have SN2, SN1, or E2. Never E1. E1 only for tertiary structure. E1 is like it only 5% occur, and that 5% will be very, very high hit. So when you have any, like when you think of any elimination reaction, don't think about E1, think about E2 first, and then when you see like 180 Celsius degree or 200 Celsius degrees, at E1 maybe occur. Okay, come back to the secondary substrate. You will have SN2 or SN1 or E2 occur. It depends on the solvent and the solvent and the nucleophile. Okay, again with the secondary halide, a strong base favor elimination reaction. A strong base favor elimination reaction because the steric hindrance in the substrate make the substitution more difficult. It also depends on the nucleophile. For example, I'm gonna scroll down over here. I'm gonna okay, this is the example. Bromine. I'm gonna use this base, MEO and A in MEOH. Give it some heat. This is not very high heat. This is just regular heat, not high heat. So when you see this kind of base, this kind of solvent, it's automatically is an E2. So you have this. That's E2, and you will have the SN2 reaction as well. Because this is strong base, so it cannot be SN1. It has to be SN2 or E2. So this case is like 75%. 75% of the elimination reaction. And you will have 25% of the SN2, which is this. This is 25% SN2. Again, this is SN2. And this is E2. E1, in this case, E1 barely occur because we can see no high heat at all. So we can just remove the E1. Okay. And another example. Let's do another example. This same substrate, but we use NaCN in DMSO. And what you will have this CN, which is the SN2, and how many percent? I guess it's 95%, and 5% is E2. Yep, but most of the time it's gonna be this. That for the secondary structure, and for the tertiary structure is E1, obviously. But okay, SN1, yep, SN1 and then E2. Remember, tertiary never for SN2. And then in this case, E1 may occur, but you have to have very, very high heat. Very, very high heat and strong base and good solvent. Good solvent. And for SN1, it depends on the base. Depends on the nucleophile and the solvent. You know that. And for the E2, most of the time it's the E2, right? For example, I'm gonna do this. Oh, this is too much. Okay. Use tertiary. This is a tertiary bromide, and I'm going to use this base ETONA in ETOH, right? And you know this base, this solvent used for E1 or E2, right? And you see there's no heat at all, or sometimes they're gonna give you 25 Celsius degree. Not the high heat, so the E2 occur. So what E2, this is symmetric, so either side can be double bond, either side can be double bond. That's the E2 reaction right here. And it's gonna be 92 or 95%. And 8% gonna be what? 8% gonna be could be SN1, right? SN1 is around 8%. Right, I'm gonna use different color. This SN1. Okay. Now if this reaction include E1, include E2 and SN1, what if I put you higher heat a little bit, not too much high, the same substrate, but a little bit higher heat, the same nucleophile and in the same solvent. I put a 55 Celsius degree, and so you see this is different. So you still have E2. Obviously, we have E2, right? Obviously, we have E2, and also we're gonna have E1 too, but not a lot. Like this one, 92%, and this one 8%, right? And what if we use very high heat, 200 Celsius degree, or maybe I put 180 Celsius degree. So E1 they're gonna switch with E2. E1 will be good sometimes 90 and 10% E2. But this case very rare. Nobody want a lot of heat in the reaction. Nobody want that. So it just cover most of the thing in SN1, SN2, E1 and E2. If you have any more questions, come by on the TA class tomorrow. Okay, or you can email me right now and ask me a lot of questions. Thank you. Bye bye.